Had to do the conversion. Review your maps. You're in the right path, but it's not the right number.
See, initially I did this.
How you doing? Remember when I said you need both units the same, both quantities the same, the unknown and the known the same.
Do we just change it to 0.1 seconds?
What's the frequency?
5 megahertz.
5 megahertz means also
5 million.
5 million what?
Cycles.
5 million hertz.
What else?
Cycles per second.
Per second. What's the other time that I give you?
Milliseconds.
Okay, you need to convert
I put it, is it 1.1 seconds?
0.1
So the
second.
answer is 5 million cycles.
No. 500,000.
So you cannot come out
500,000.
Count the zeros.
Oh, I just
that's when your
That's when
ability to do those multiplying by decimals.
I accidentally wrote it down.
You got it, Supan?
I was going too
How much?
fast.
500,000 cycles.
But I just
Okay.
wrote it down.
You got it now? You have to be careful with your little decimal points.
Top me.
All right, I think we got enough with that first portion. Then the next, so in transducer frequency cycle per second, the reciprocal to that will be, it's called the period. In that range of megahertz, the period usually is in microseconds. You have to remember that megahertz or anything in hertz is that number in 1 second. Right? In this case, megahertz means million cycles per second. Whatever number is 5 to 10 million cycles per second. To find the period, you do the reciprocal. 1 divided by whatever frequency that transducer. All right, the next frequency is what?
PRF.
PRF. The reciprocal is PRP. What is PRF? Number of pulses. All right, you guys finished?
Yes, sorry.
All right. The next frequency is PRF, means number of pulses that the system can produce in 1 second. Number of pulses that the system produces in 1 second. Because of that, also the unit is in hertz. The system, because the average patient size, human body, is between whatever 1 millimeter and 30 centimeters deep. We don't go more than 30 centimeters. E average or is in the range of kilohertz. The system can produce thousands of pulses per second. Okay? 1,000 pulses per second. Once again, if we know the frequency, we're supposed to know how to find the time, the reciprocal. The reciprocal to pulses per second will be PRP, the pulse repetition period. The PRP is how long it takes for the system, for the pulse to go and coming back to whatever depth you set up. So with that definition, what's the most important factor? The depth. And that you should remember from now till forever. The most important factor that determines PRF is depth. The most important factor that determines your frame rate is depth, distance. You control that.
So the most important factor that determines PRP is depth, but the one that determines, what did you say? The frame,
Which is
Frame
also,
is the distance.
It's also-
Depth
Yes.
and distance?
Yes. Yes. All right. With the pulse, we have several factors, several parameters to consider. Here, we have to deal only with period, number of cycles. When we come into pulse, number of pulses that can repeat in 1 second, we have more parameters. What are those parameters? The PD, pulse duration.
You can make a new thing.
Usually the question will be, what is the PRF? Because it's the easy. And the first thing you need to calculate is the PRP. Same as with the frame rate. They will give you certain data and you need to calculate the frame time. Once you find that, then you calculate the frame rate. Same as here. To calculate the PRF, they give you certain data that you will be able to calculate this first. Once you find this, then you can find the PRF, because you know this magic formula. Right? PRF is 1 divided by PRP. So what we have here, what parameters? Pulse duration. What else? SPL, duty factor. Here we have beside the period, we have also the wavelength. Wavelength here.
Wavelength for the.
it's her frequency of transmission.
Just make a new one then, because I'm you don't have to erase that. You can just push plus. At the bottom.
What is the wavelength?
See over that.
Yeah, exactly, so because you're like,
A big source of confusion
you see it long in front of you.
in this portion. What is the wavelength? The space. Kind of, like we say the period. What's the period? The time for one event, the time for one cycle to occur. Right? Here, is the time, the distance that cycle, that event takes in the space. This is the distance. How we calculate propagation speed? By the frequency. The frequency is here. High frequency transducer have low. Low frequency transducer have high. Super easy. Which one is better for imaging? Bigger or smaller? Small. Which one will give you a small? Higher frequency. Here is where you guys get confused. What happened to the wavelength? What happened to the wavelength if the sound being changed from soft tissue to gas? A bunch of questions will be like that. Use this formula. Use this formula. Whenever that kind of question, changing the medium, you realize it when the sound changes from soft tissue to gas, or from bone to soft tissue, or soft tissue to bone. You come in here. Okay, it's changing from soft tissue, 1540 meters, to gas. What is this increase or decrease?
That
Decrease.
This decrease, therefore this decrease. Right? You just come into this formula. Or when you say what happened to the wavelength when you change the frequency of the transducer from 6 megahertz to 12 megahertz, what happened to this? Just write your little formula. Everyone remember this formula. Why you guys cannot do that? See? Are you okay? You look worried.
I'm trying to
Be happy.
remember
Be
what I
happy.
did in the test. I don't know if
Okay, the test is over. Now you have to move
but that
on.
it's still content from the test.
Okay?
And that's gonna keep
But now
keep on
it
coming
makes
up.
easy for you now.
You get it?
If you remember this, and then you work with arrows. You work with arrows. Okay. If it's this, from soft tissue to bone. Okay. Soft tissue 1540, bone is what?
45.
So it goes up. What will happen with this? It goes up. The wavelength gets longer. What happened with the frequency? If you change your frequency from 7 megahertz to 3.5 megahertz, what happened to
Goes
this?
down.
Goes down. If this goes down, this goes up. All right? You have like 5 or 6 different questions that you could do with this. You write this formula in the side, and then you play with arrows. You know how to manipulate these arrows according with what is changing, right? If this change goes up, this goes down. If this goes down, this goes up. If this goes up, this goes up. And that's called critical thinking. Critical thinking. You bring that here. Critical thinking. All right, enough with that. Let's deal with the next thing. PRF. What happened to the PRF if we change the depth from 15 centimeters deep to 10 centimeters deep? What happened to the PRF? Or, yes, what happened to the PRF? From 15, if the depth is changed from 15 centimeters to 10 centimeters. What happened to the PRF?
Increases.
You got it?
Time goes down, so the PRF goes up.
It's all how you present your problem. What you got?
Makes sense. I just wrote the question down, but it makes sense. We'll have more trips, less depth, you have more trips.
Okay, so the PRF
Goes up.
goes up. You got that? All right.
No, explain it
Once
to me.
again, you
Can
can-
explain it to me more?
All right.
Lakeland, Orlando.
How you calculate the PRF?
1 over PRP.
1 over PRP.
Yeah, next up.
Yeah. If the PRP, when I change from 15 to 10, gets smaller or larger? Smaller. If this gets smaller, what happens with
Yeah,
this?
it's larger. Oh, okay, okay, I get it.
You see, the same thing that you work there.
Yeah.
What is the most important factor?
Depth.
That.
Depth. We'll go later on to frame rate. The same thing. Depth, because depth is what controls this, determine the PRP. And the PRP determines this. Later on, we'll see that this also influences when we calculate the frame rate. All right, about this. What's PD?
Alteration.
Times number of
Cycles.
Times what?
times what?
Period.
Period. False duration. Which transducer will have a, assuming this is the same. If I have a 5 megahertz transducer, then I move to a 3 megahertz transducer. What will happen with the PD? Go up?
If the frequency goes down and the PD goes up.
If the frequency goes down, what happened with this?
I guess
Goes up, right? So this goes up.
longer.
You got it? All right, that one is very similar to SPL. Here is a little more complicated because SPL is number of what?
Cycles times wavelength.
Right? Well, if they tell you, if they increase the number of cycles in the poles, of course the PD will increase. If they increase the number of cycles in the poles, the SPL will increase, right? But the problem for you guys is the question there will be, what happened to this or what happened to this if they change this or this? Or they can say if they change the frequency here. If they change the frequency here, or if they change the frequency here, how that will affect here. You just do your little formula. Even you can do your little, replace this with a little formula that you know what's the wavelength.
C over F.
C over F. You replace this by the little formula. What happened to this if the frequency changed? Okay?
Do you remember the one on the test? What was it? Like the bonus question?
I have 50 questions.
It was like, I think the answer was, I don't even remember, but I think I got it wrong.
I got the bonus.
I don't remember it.
Which one was
I don't
that?
know.
It was like the,
I just know
it was
I got it
something like that though, like if,
Yeah, it had to do with period.
yeah,
It had something to do with period, and I used that formula and I got it wrong.
yeah, I used that formula and I got it wrong.
Yeah. I forget what it was, but I remember I was doing the arrows and I
Yeah.
was doing all that and I came out wrong.
Let me see, what was the,
I don't remember.
Period.
Who will remember?
I took a picture, but recording, I don't know if.
all right. we already went over some of this, the duty factor. There's this divided by
PRP divided by PRP.
PRP. So you can do this PD divided by PRP. How this affect, what this is affected by? Depth. And usually the question will be, how the duty factor change when we change the distance from 10 to 5 centimeters, or from when we change from 8 to 15 centimeters deep. How this will affect? Well, use your formula again and work with the arrows. When they say change the distance, this is changing. Longer the distance, gets bigger. Shorter distance, this gets smaller. How this change affect this? Once again, work with your arrows.
Please remind me what the duty factor is.
The duty factor is a ratio, it's a comparison of times. Pulse duration versus the PRP. Usually will be a small percentage because this is usually tiny comparing with this.
I remember the question. Sorry. It was, she just explained me why I got it wrong though. She said that what happens to the period if the propagation speed changes, and they're not related, so that's why it's unchanged.
It was too easy, that's why I didn't
Yeah.
remember
Well, I
what
was
I
trying
asked.
to do the frequency is 1 over period, so then I did the period goes down, the frequency goes up, and then I put it in that formula again.
It was so easy, I couldn't remember.
It's not related. Yes.
But do you see, guys, now how if you remember the formula, when they ask you those, I think the majority of you screw up with those questions because you don't know what to do with the wording question. If you kind of, and then the main thing in the group of words is what's the question? What's the question means which of these concepts you need to write it down in a short note, in a formula. Once you work with arrows like that. You got it? What is that? That's not physics.
Critical thinking.
Critical thinking. Critical thinking and practice. All right. Let's go a little more farther. What is SPL? What's important? Why do they come in your head?
Axial resolution.
The axial resolution. What's the axial resolution?
Longitude.